And I want to introduce our guest speaker now and not eat up everybody's time. Dr. Chuck Thorpe is a professor of robotics at Carnegie Mellon University. Been doing that for 20 or 30 years. And is also a former dean of Carnegie Mellon's Qatar campus, so with a great deal of global experience. I also found out during our car ride that he was raised in the Congo. So last night we put him on the spot and found out how he went from the Congo to being a robotics expert at the White House. But we're very lucky to have you here with us, Dr. Thorpe, and we look forward to hearing what you have to say about the President's plans for robots. Thank you.
Thank you to the sponsors, to RoboticsAlley, to MHTA, to the Humphrey Center. Thank you for bringing me up here, and thank you for feeding me breakfast. If I'm not mistaken, those were powder milk biscuits. Raised by Norwegian bachelor farmers so that you know that they're pure mostly. There we go, thank you. I'm here to tell you a little bit about what we're up to in DC on robotics. I'm going to tell you a little bit about who I am, about what the President is up to, the National Robotics Initiative, where we are, and some things that I think we should be doing together. And I've got a couple of videos to show. My own background, I've been at Carnegie Mellon for a long time, and what I do for a living when I'm actively researching is to build robot cars. So this is now a few years old, but it gives you a sense of sort of the grandfather of the DARPA Urban Challenge. When I started building robot cars, it took this big of a vehicle just to carry the computers. I had onboard sensors, onboard computers, and very importantly, onboard graduate students. You'd be surprised how much the quality of the software improves when the graduate students know that they're going to be first at the scene of the accident. But we were able to drive. Here we are driving through my neighborhood using a vision system to see the road and looking for obstacles with a laser scanner, like my son. And it sees him in 3D and hits the brakes and stops and waits for him to get out of the way, and then it's willing to pick up speed and keep on driving. This is the forerunner of a lot of things we're doing. By the way, I've inspired him to get a master's degree in robotics and to work in automotive safety. So we've had some good backgrounds. And then we went out and drove faster and ended up eventually doing a program called the Automated Highway Program, where 15 years ago we had robot cars, robot trucks, robot buses driving by themselves along the road, talking to each other, so that if one vehicle sees an obstacle, it can tell the other vehicles where that is, and they can change lanes before they even get there. The whole idea is to be safer, smoother, less impact on the environment. A lot of people talk about high-impact research. I'm into low-impact research. Let's avoid these collisions. Let's make our roads safer and more productive. And there's a good group here at the university that works on that same set of problems that I work with. Well, then I got tapped by Carnegie Mellon to go to Qatar to set up a new campus, and they built us a beautiful building. We had a lot of cool visitors, U.S. secretaries coming through. When Sir Richard came through, they said, don't ask him about the space plane, because he won't talk about anything else. The coolest part about being in Qatar was the students, of course, students from 34 different nationalities. Even in Qatar, we found a chance to do a few robotics things. This is a multilingual robot receptionist, a lot of human-robot interaction kinds of work. And here's an application that I had never thought of before, robot camel jockeys. All right. Now I'm spending this year at the White House helping with robotics. Do you know there's 8 million robots out there in the world? Do you know what most of them are? 7 million of them are that. About 10,000 of them are that. And you'll notice this is actually the same company that built both of them, so they're hedged against changes in either of the state of the art. And then there's about 1 million assembly robots out there. and they're doing all kinds of cool things. But when you look at, last year was the 50th anniversary of the industrial robot. We talk about human-robot collaboration, and there's a fence around the robot. How come there's a fence around the robot? Well, if you have 500 pounds of steel with no sensors on it, trying to get to a particular location to within 1,000th of an inch, you don't want to be between that robot and the location it's trying to get to. So the state-of-the-art in human-robot interaction is you power off the robot, you open the door, you walk in. This makes it really tough. We know that robots are good at a bunch of things. We know that humans are good at another bunch of things, but there's these fences in between them. How do we make humans and robots able to work with each other better? Fortunately, about 4 years ago, the community got together and for the first time actually acted like a community and built a roadmap for what the robotics world should be doing. Also, fortunately, the president likes robots. We were talking about hockey. The president said, look, we bring the winner of the NCAA basketball championship to the White House, and that signals that basketball is important, and the president likes basketball. But science and technology is important too, so let's bring the winners of the science fair there. His aides have mixed feelings about this. They sign up the president for a 5-minute time slot to go have his picture taken with the kids, and 45 minutes later he's crawling around on the floor saying, now explain to me why you're using wheels instead of tracks, and did you guys see that pan tilt? And the aides are saying, sir, the ambassador from India has been waiting. He said, yeah, but did you see? So that's really cool. The president came actually to Carnegie Mellon last June and gave a speech where he talked about a variety of different things. He talked about the Materials Genome Initiative. Let's find new ways to build materials, to work with them, to join them, to cut them, etc. Let's talk about advanced manufacturing. Let's work on a strategic plan for advanced manufacturing in this country. Let's make sure that things which get invented in this country get manufactured in this country. The full report on that is coming out in about a month, and I can't talk about it until it's officially approved. But already the president has announced $1 billion to set up a network of manufacturing innovation institutes, led by industry, big companies, small companies, universities, community colleges. I think you guys should take a very careful look at that and be one of the groups that compete seriously to bring one of those manufacturing innovation institutes here. And there is the manufacturing.gov website that has the details on it. Well, when the president talked about robotics, he said, I am the commander-in-chief, and one of my jobs is to keep an eye on the robots, and despite what Daniel Wilson says, they still appear to be peaceful. That's what he said. What he meant to say was the following. We've got multiple missions in robotics. We have an engineering mission to build the workforce of the future. We have a scientific mission to understand intelligence. We have an educational mission, both to educate people about robots and to use robots to inspire people. And we have a tech transfer mission to make sure that the robot revolution happens here in the United States. So the National Robotics Initiative came out of that. This is a group of different projects at different levels, all working together. The core part of it has received over 700 proposals, totaling over $1 billion. We probably only have $50 million to spend on it. So part of my job at OSTP is to make sure that there's more money for this next year, because there's so many good ideas, we don't have enough money to fund them all. The NRI multi-agency initiative is led by NSF, but it also includes NASA. I like these different pictures of NASA robots. The one on the top right, those are the K-10 robots. K-10, their predecessor was K-9. Get it? And this one, that's a robot on the surface of Mars. And here are its tire tracks as it was driving across. Is that cool? That still gets me excited, and I'm a long ways away from being a middle school kid. Department of Agriculture is one of the partners. Intelligent bug traps, so you can tell what kinds of bugs you've got. And then I really like this one. They're doing pruning. The robot is doing the driving, and the humans are the intelligent end effectors. How's that for human-robot collaboration? And of course NIH with all kinds of different applications, surgery, rehabilitation, prosthetics. In order to have humans work with robots, there's a whole bunch of different things you have to do, not just robot construction, although that's important, but also human-computer interaction, systems of robots, etc. So this is a cool project that's going to be launched as soon as they're finishing with the review of these programs. Well, what does it take to have humans cooperate with robots? Lots of different things you can do on that. Some of it has to do with interesting mechanical design. Here's a case where this was actually work done in Germany. Yes. Let me see if I can get this to fire up. Work done in Germany with robots that are so dexterous and have such a fine sense of touch that if they hit you, they react quickly enough to keep from poking a hole through you. These guys take their inspiration from Isaac Asimov, who changed the image of robots from dangerous robots to friendly human cooperative robots. This is important stuff. Have I completely killed the... No, there we go. Other ways that you can have humans and robots cooperating. How about flying robots? Wouldn't it be great to send a flying robot into a burning building to see if there are people in there that need to be rescued? Wouldn't it be great to have a flying robot, small, cheap, lightweight, won't hurt anybody if it runs into it, going into a hostage situation? All kinds of ways you can have humans and robots cooperating and those kinds of things. You can have humans and robots cooperating by having robots carry heavy loads for you. Oh, let me see here. I might be able to show you that video after all, and I might not. All right, that didn't... We have not yet worked on cooperative humans and computers. Do you guys know about Big Dog? So this is the predecessor of... They've now introduced the robot Cheetah, which can run 18 miles an hour. The soldiers love this because they're tired of carrying those heavy loads. So if this can help out in our warfighters, that's great. The roboticists love it. I start to worry about the Cheetah when the Cheetah can run faster than I can. Now all of a sudden you've got human-robot safety issues that you have to deal with. So the evolution of robots being able to do useful things for you. How about sending robots out to do ocean patrol, looking for mines in the ocean? There's a number of different approaches to doing that. And the question is, what do you call an unmanned ship? And of course, it's a rowboat. How can humans and robots collaborate? Here's another way. How about if robots can learn from humans? This is a 68 degree of freedom robot with hydraulic joints, and trying to program 68 degrees of freedom is very difficult. So this one learns. It learns by watching these guys, and these guys don't play air hockey terribly well, but it learns sometimes you hit left, and sometimes you hit right, and sometimes you hit straight, and then it can play air hockey. It's not playing very well. Well, it just beat that guy. So the notion of humans and robots collaborating together to learn from each other is a big deal. You know, and if you can build software to control a 68 degree of freedom robot arm, you can use that same software to solve other high degree of freedom problems like protein folding. The same software that controls complicated robots is useful in drug discovery. And robots helping the elderly people. This is my friends at Georgia Tech. They wanted to know if you're wheelchair bound, what would you like to have a robot do for you? So they started a poll. What are people most worried about picking up that they would want the robot to pick up? If you were sitting in a wheelchair, what would you be most worried about dropping? Any thoughts? TV remote control. If you can design a robot to pick up the TV remote control so you're not stuck watching Oprah for 8 hours until somebody comes home. And credit cards, and et cetera, and your keys, and your glasses, and your phone. And so they have to design manipulators to do that. And then they give the person a laser pointer so the person can point and say, pick up that thing right there, turn off that switch right there. If you get the people in the act, it makes it easier for the robots to work. This is one of my favorites. It's an all-for-cute little robot toy. And I thought, why in the world? It won a robot business plan competition. The toy didn't, the company did. I said, what is that good for? Well, for use in autism research. It waggles its ears and it coos and it bats its eyes. And so for kids who have a hard time with the motive response, this really helps them with that. This, of course, is not a U.S. issue alone. We have competition around the world. Someone asked me how international is robotics. I went to the Handbook of Robotics and added up the authors. You can see they come from lots of places. This is not a very accurate survey. You can see how many authors come from Italy. I think some of that has to do with Bruno Siciliano as one of the co-editors. But it does give you a sense that we both collaborate and cooperate all around the globe. Well, so this whole push for friendly humanoid robots is nice. And the people who've been leaders in this for a long time are the Japanese, the robot girlfriend. And that's great to have friendly robots until something goes boom. And the quip is that the girlfriend robot refused to walk into a burning nuclear reactor carrying a Geiger counter. When you have a disaster happen, you need real robots that can do real work. Of course, this couldn't happen more than once, could it? These guys sent in a robot called Quince, which was an experimental robot designed at Tohoku University. Quince has got great big lugs on its tracks, so it can go up and down all of the staircases. This went further into the reactor than any other robot did. It eventually wrapped itself around its own tether cord, broke its tether cord, and wasn't able to continue. But for an experimental robot, it did great things. Kinetic sent over robot Bobcat and a robot Talon to find stuff outside of the reactor, the bits of spent fuel, to scoop them up, to store them away safely so that the radiation levels would be down so that humans could approach the plant. And iRobot sent over one of their PackBots. They sent over this PackBot, they opened the double doors, shoved it in and closed the double doors, and you know what happened? The lens fogged up. Of course, it's hot and it's humid in there. They opened the double doors, they pulled it back out, they cleaned off the lens, they put on some anti-fog, they opened the double doors, shoved it back in, closed the doors. The PackBots have been in and out now for lots of months, but they can't go very far into the plant, and there's a limit to how much they can do. So it's great that we have robots, but it's not nearly great enough. We really need to have robots do much better things in there. Of course, this would never have happened again, huh? The Robotics Institute at Carnegie Mellon got its start with 3 Mile Island, building robots like this that went and operated for 4 years in the basement of TMI. Well, this could never happen more than twice, huh? Chernobyl, when that happened, the Russians said, we don't have any nuclear disaster robots. They brought out of mothballs one of their Marzakad prototypes. The good news and the bad news about the Russians is that their electronics were so primitive, it was mostly run by relay switches, which isn't very sophisticated, but is automatically rad hard. So by putting a dozer blade on the Marzakad, they were able to save a lot of lives and get a lot of work done. And Carnegie Mellon also built a robot that went into the basement of Chernobyl and did some work. Well, this is good. The French have some robots, not terribly sophisticated. They take commercial robots, they put a really long tether cable on it, they put some rad hard electronics on it. The Germans have some robots, again, the same kind of thing. I think that we really need to do a much better job than that. So I poked around the US government to see who's got ideas and talked to some people. If you want an interesting robotic technology, how about recon robots? Rather than crawling through the rubble, why don't you just take one of these things and throw it across the rubble and it can see what's on the far side? Or, and there's soldiers doing it in combat, you can also do it in a nuclear reactor. I talked to the power systems people. They said, yeah, we've built lots of rad-hardened robots for work in the processing plants. We know how to do this kind of stuff. So I threw a workshop where I said, okay, let's get together. Let's talk about what it takes for rad hardening. And then let's talk about all of the kinds of things that a robot should have to do. Nuclear power plant has ladders. There are very few robots in the world today that can go up and down ladders. It has high reaches. It has some things that you need to do, open a valve, close a valve. Maybe you need some underwater robots to get into some of the tanks, et cetera, et cetera, et cetera. If you set out a roadmap to do all of this, basically you've set out a roadmap to solve the robotics problem. DARPA just yesterday announced a robotics challenge. They didn't say what these robots are for, but it's a robot that can cross a rubble field and open a door and climb a ladder and find a leaky valve and sound familiar? This is good stuff. I want the world to work on these problems because these are crucial problems for our ongoing safety and security. Well, that's one example. Another example, we've always worked on military robots in the most difficult, dangerous places in the battlefield. I said, this is great, we should do that, and let's also see if we can get them working on in military bases where it's a better controlled environment, where you don't have to distinguish friend and foe, you hope that everybody is friends. And let's see what we can do with those robots today. I went to see Lieutenant General Lynch. Lieutenant General Lynch has been following robots since 27 years ago when he was assigned to come tell us pointy-headed academics what the military needs. Part of his lecture to us 27 years ago as Captain Lynch was, sirs, if you want to know what it's like to operate an M1A1 in combat, you should read the latest Tom Clancy. They just rip the governors off their tanks and they're going 60 miles an hour and they're bouncing over the dirt roads. And, sir, that's what it's like to operate an M1A1 in combat. I went to see Lieutenant General Lynch. He said, oh, Chuck, good to see you. He said, did I give a hell of a talk at the AUVSI? I said, sir, you gave a hell of a talk at AUVSI. He did. He said, every morning I go into the Pentagon, I get out my Bible, I get out the 145 laminated pictures of the brave warfighters who died under my command in Iraq. 120 of them were doing jobs that should have been done by robots. You guys are so good at inventing, how come you haven't gotten them deployed yet? I said, sir, I'm here to help you figure out how to get those deployed. Let's get these robots deployed on the bases, and then we'll get some experience with them, and then your warfighters will demand them when they go into battle. He said, well, what can robots do for me, Chuck? I said, well, sir, does the military ever need to carry stuff? Duh. Sir, here is the Oshkosh truck that you rode in at your robot rodeo. We can carry stuff for you today. Sir, do you need to carry more stuff? Here is the 445-ton dump truck that Caterpillar has just automated. And by the way, Peoria is within your circle of your robotics alley. Caterpillar has sold 45 of these to a strip mine in Australia. If these can run in a mine in Australia, sir, they ought to be able to run on a military base. Do you need to operate? Does the military have any warehouses? Of course the military has warehouses. Sir, here are two different solutions of robots operating that can save you manpower, save you money on your bases. Sir, do you have any garbage on military bases? Here's an experimental robot picking up garbage in a village of untrained Italian villagers. Sir, if this can work cooperatively with untrained Italian villagers, it can work with your soldiers. Sir, do you have any floors that you need to clean? This is actually cleaning the floors at West Point. There's some sergeant somewhere who's mad about this because he used to assign KP duty to his... But I'm sure that sergeant has enough imagination to come up with other forms of duty. Sir, we can give you the cleanest floors in the world with robots doing that. Sir, do you need to patrol perimeters? Here is a robot that can patrol your perimeters. This was actually built by the Army. By the time they got done building it, it was too expensive, so they gave it to Department of Energy. This is actively patrolling the Nevada nuclear test site today, and there are ways of making it cheaper, these applique kits coming out of companies like this. General Lynch looked at me, he said, this is all great. He said, I own 145 bases around the world. You tell me what kind of conditions you want. Do you want to test in typhoons? I got typhoons. You want to test in ice? I've got ice. You want dust storms? I got dust storms. Only question is, who's going to pay for all of this? I said, sir, my office is right downstairs from the Office of Management and Budget. Let me go to work on that. It turns out that sometimes the technology is easier than the bureaucracy. I am still working on trying to find the right way through the process to get funding to get some of these things deployed on military bases. There are opportunities here for you guys. Andrew already has robots being deployed on military bases doing inspections. And lots of other things. When we start to get into logistics, not only does the military have warehouses, but companies have warehouses. If we start to get better information about what's in the packages, if a robot can read a barcode and go look on the web to say, oh, here's how you pick up this box, here's how heavy it is, here's how delicate it is, we can revolutionize the way that we handle our warehouses. So when I put all of this together, of course there's lots of work left to be done in robots. To really make robots completely easy and friendly and around the house and so that your grandmother can use them, there's lots of areas where we want to keep working. We're not done with those. We have good careers ahead for our robotics researchers. But there's a lot of places where the robots are ready for deployment today. The robot revolution is here, and they're still peaceful. Thank you very much.
So everyone who's been to a Leadership Insights lately knows that next what we do is you turn to someone around you, you introduce yourself and discuss what you just heard for about 5 to 7 minutes, and then we'll do question and answer. And one way to do that is to talk about what you might ask Dr. Thorpe and maybe refine the question and have it be an even better question when we come back for the Q&A. So about 5 to 7 minutes, introduce yourself to someone around you or a couple people around you in small groups. Have a little bit of a discussion. We'll be right back with you. All right? Thanks. All right.